Imagine asking an AI assistant a question and getting an answer instantly, even if your internet connection is slow or completely gone. That future is being powered by something called Edge AI. But what exactly is Edge AI and why are companies racing to put AI directly on our phones, laptops, cars, and even smart glasses? Let's break it down. For years, most AI systems worked using cloud computing. When you typed a prompt into an AI chatbot, your device wasn't actually doing the thinking. Instead, your request traveled across the internet to a massive data center filled with powerful GPUs. The AI model ran there, generated a response, and sent the result back to your device. This architecture made AI possible at a large scale, but also created problems. Every request requires internet connectivity. Every response introduces network latency, and every AI query costs money because companies must pay for expensive servers and electricity. As AI usage exploded, these costs started becoming enormous. This is where Edge AI enters the picture. Edge AI means running AI inference directly on a device instead of sending every request to the cloud. The term inference refers to the stage where a trained AI model is used to make predictions or generate outputs. Think of AI development as having two phases. First, training. Training requires huge amounts of data and computing power, so it usually happens in the cloud. Second, inference. Inference is when the trained model answers questions, recognizes images, summarizes text, or generates content. Edge AI moves this second phase onto the device itself. So instead of your phone constantly asking a distant server for help, it can perform many AI tasks locally. This creates several major advantages. First is speed. Because data doesn't need to travel across the internet, responses can be nearly instantaneous. Second is privacy. Sensitive information can remain on the device rather than being sent to external servers. Third is reliability. AI can continue working even when network connectivity is poor. And finally, there's costs. If millions of users perform AI tasks locally, companies don't have to pay for cloud inference costs for every single request. But here's the challenge. Modern AI models can contain hundreds of billions of parameters. How do you fit something that large onto a smartphone? The answer is model distillation. Distillation is a process where the smaller model learns many of the capabilities of the larger one while requiring far less memory and computational power. Think of it like creating a condensed version of a textbook. You lose some details, but you keep most of the important knowledge. Over the past few years, distilled models have improved dramatically. Many small models can now perform reasoning, coding, language understanding, and image processing tasks that were previously only possible with much larger systems. This is why AI capabilities on devices are growing so quickly. But does this mean the cloud disappears? Not at all. The future is likely a hybrid AI architecture. Simple and frequent tasks happen on device using Edge AI. More complex requests get sent to the cloud when additional computing power is needed. For example, your phone might summarize messages locally, while a complicated research question could still be handled by a large cloud model. In other words, the cloud trains and supports the models while edge devices increasingly run on them. Many experts believe this shift is as significant as a transition from desktop computing to smartphones. In fact, some people are calling AI the new user interface. Instead of clicking through menus and apps, users will simply talk to intelligent systems and understand context and perform tasks directly. And for that vision to scale to billions of devices, AI needs to run efficiently at the edge. So the next time your phone edits a photo, translates speech in real time, or summarizes a document without contacting a server, remember what's happening behind the scenes.